Hi, welcome to the first edition of the AWS Quick Start. Today we're going to start off by running you through mechanisms for cost optimization on the AWS platform. What I'm going to focus on today is organizations, if you're just starting your AWS journey, what tools and what mechanisms you can look at for your future use to help you with cost optimization. Or if you're already running workloads, for example, EC2 or RDS, what you can do to cost optimize what you have running today. My name is John Janes. I've been with Amazon Web Services for just over 2 years, and during that time I've worked in the Australian office helping Australian customers with workloads on the AWS platform. Throughout that time, one of the primary focuses of my role has been helping customers cost optimize. What I want to discuss with you over the next 30 minutes is cost optimization and 3 subtopics within that wider discussion. The first one I want to discuss with you is around establishing cost visibility. The establishment of cost visibility is key for your success on the AWS platform, particularly around cost optimization. Once I've gone through the mechanisms that you can use to establish visibility, then what I want to talk to you about is 5 main pillars in regards to optimization. If you look at these pillars, typically what customers experience is around 20 to 30% savings in your EC2, RDS, Redshift, and other associated services costs. So it's a very valuable mechanism as you're going through your cloud journey. Then to summarize at the end, I want to take you through what a typical optimization journey looks like. So it's in AWS, a cyclical path, and how you can start with optimization today, where you might be in 6 months and 12 months, and then how you continue to reiterate that process. So to start off today's discussion, I want to spend the first few minutes around establishing visibility. As I mentioned, this is the very first step in regards to cost optimization, and it's crucial in regards to your AWS utilization. When you're onboarding workloads into the AWS environment, sometimes it can feel like you're moving from maybe a traditional car to a fast-moving machine. And that fast-moving machine introduces new components or elements into your organization. It introduces things such as speed, the ability to procure services and technology resources very rapidly. But that can also increase complexity, and now that you have to manage all of these new resources and different components. And it can be an analogy from an old car to a very fast car. So as we're going through that journey, what we want to do is enable you to have the right tools and mechanisms in place so that you can measure what you're doing. Measurement starts with tagging resources. So this is the very first thing I want to mention to you in regards to cost optimization, is implement a key tagging policy so that as you're introducing new workloads or you have different various business units interacting with services in AWS, you can cost allocate them. Once you have that cost allocation running and you have tagging going on, then what you can start to do is get detailed information into the consumption using a number of different mechanisms. The first mechanism that I want to walk you through around visibility is taking a look at your AWS monthly invoice. At the end of the month, every month, AWS will send you a detailed summary report of all of the services that you've consumed. This will be broken out in your AWS monthly invoice. In this invoice, you'll see a number of different things, such as your AWS accounts. You'll see multiple accounts if you have consolidated billing. But under each of the accounts, you'll see consolidated service spend. So whether you're using AWS EC2 or Redshift or RDS, you'll see a line item broken out for each of these different services. And this is where you can start to first establish good visibility into what you're running on the AWS platform. If we go back 2 minutes ago to where we had the analogy with complexity increases and we need to introduce new components to monitoring and visibility, we can move left to right on this slide that I have for you right here. And the next area that you'll look at typically is your AWS Billing Console. Your AWS Billing Console is a key area to show you what you've billed so far in the current month on the AWS platform. It'll also give you a projected view at what we think your consumption will be at the end of the month. Also contained within your billing console is an additional service called AWS Cost Explorer and AWS Budgets. I'm going to run through some of these in more depth in the session, but effectively AWS Cost Explorer is a graphical user interface where you can look at historical billing over time. It's an excellent service that you can look at your spend over the last 6 or 12 months and then break those out by different services or different metrics that you want to monitor. Once you have start to monitor those metrics, then you can use that data in regards to cost optimization, and I'll start going through those mechanisms in a few minutes. The last area that you can look at to get visibility into your AWS account is looking at your AWS detailed billing report. So AWS detailed billing is something that you can enable within the AWS Preferences console, and it allows you to get a raw export, which is dropped into S3, around all of the AWS service consumption that you have in a given month. What you can do with this billing report is you can use it to run your own analytics on top of it using your own tools, but also it can integrate with third-party tools. I'll give you a lot of examples during this discussion today around third-party tools, and a lot of them utilize these billing reports to give you visibility and measures on what you're doing on the AWS platform. As we mentioned, environments can start off simple. So you could start off with just a web page, something relatively easy to deploy, or you can move into complex ranges running large workloads on the AWS platform. And your requirements for visibility might increase. So you might go left to right throughout your AWS journey. So going into the core of today's topic, once you've established visibility, once you have tagging in place and you know where costs are being incurred, how do we optimize those costs? How do we make sure that you're running the most efficient services or machines that match the workload that you're running today? And what I want to take you through is those 5 technical pillars. And this is the core of today's discussion. The first pillar I want to take you through in cost optimization is around right-sizing and decommissioning unused resources. So this is really around how do we match what you're running on the platform versus what your applications or your users or your workloads need in as real time as possible. As we go through left to right here, so right-sizing, the next area that you'll typically take a look at is how do you increase elasticity? We look at elasticity in the AWS platform as having dynamic workloads that can scale up or down based on that workload's requirements. So I'll walk you through some mechanisms that you can use to increase elasticity, which will help you cost optimize your AWS workloads. After you've done these first 2 steps, so after we've looked at right-sizing the content or the environments that you have, and you've introduced any elasticity that you may want to, you can look at using reserved instances. And I'll give you details around how you can look at 12 or 36 month terms, and in regards to those commitments, what discounts you can get on your AWS consumption. Going a little bit deeper, so after we've looked at the compute or the databases in regards to the first 3, we also want to help you optimize your storage that you have provisioned on the AWS environment. So I'll talk you through how different storage patterns can affect your AWS costs. And then last, I want to talk you through designing for cost. And designing for cost is really around using emerging technologies or serverless components, and then how those can help you with cost optimization on the AWS platform. So jumping into the first one, the first pillar, right-sizing your resources. So right-sizing resources on the AWS environment really goes in the vein of always selecting the cheapest instances or resources that match your requirements. If we're talking about EC2, there's a few main components that you want to look at that your applications will have requirements for. And those requirements can be around the CPUs that you provision, the RAM, how much disk you provision, and then any considerations you've made in regards to network. Now, unlike traditional IT capacity where you had to potentially grow into IT resources, or you procure something and you have to try and maximize that, you can mix and match AWS resources on demand. So if a resource isn't the appropriate one for you today, tomorrow you can very well go down, or even today you can go down and you can change and configure that. So you can change an instance to be larger or smaller to meet the exact requirements that you have. An example of how right-sizing is very important and how it goes into the vein of cost optimization is in how, an example of how resources will be in regards to cost from large or small instances. So I want to give you a quick example of how we've right-sized one particular instance. If we look at an M4 4X large, on demand, that instance costs $1.72 per hour. Maybe we just migrated this in or provisioned this, and after a little bit of time, we've done a check. We've grabbed metrics around our CPU and our RAM, and I can understand that this particular resource is a little underutilized, so it's at 20% CPU utilization. If we were to look at right-sizing this particular instance, we could look at, instead of deploying the M4 4x large, we could deploy an M4 large. And in this case, an M4 large costs 21 cents per hour, opposed to $1.72 that an M4 4x large costs. After making an adjustment on the fly and right-sizing this particular instance, we can review and make sure the application is still stable and we have the required capacity. And then if we want, we can then run that resource within the new instance. An example of how this cost optimizes this particular workload is that change in dollar price per the hourly rate that we're running. And in this essence, it saves us 87%. And this is just through changing the resource size. So you want to always make sure you're running the leanest and the cheapest resource for your particular workload. So that's the first area around right-sizing. In the same capacity as right-sizing, you want to look at decommissioning unused resources. Oftentimes what happens is when you are shutting down or rebuilding EC2 or other various services in the AWS platform, depending on your configuration, you might find that you've accumulated some unused capacity. And typical things that you might find are unattached elastic IPs or unattached EBS volumes. If these are no longer required, because they are still provisioned, they're going to be incurring cost. If they're no longer required, you can very easily turn them off and then stop paying for that additional charge. In line with unattached EBS volumes, if you no longer need that volume, you could potentially take a snapshot of it, get rid of the volume, and then you just have the backup if you do need to bring back that disk at a later time. Idle EC2, RDS, and Redshift instances are also ones that you can look at turning off. I'll talk about some measures that you can do in a little bit around AWS CloudWatch. But if resources aren't being utilized and they're still running, you can very easily just turn them off, and that resource is still available to you, but you won't pay the hourly rate because it's shut down. So there's a number of tools that you can look into the industry and how do you help right-size and look at unused resources on the platform. From an AWS side, we have a number of different services that you can take advantage of. And the first one I want to introduce you to is AWS CloudWatch. So AWS CloudWatch is a log and metric analysis tool where you can ingest logs and then over time graphically look at the information that's presented to them. Examples of that include CPU or memory if we're looking at EC2. So you can use AWS CloudWatch as a mechanism to monitor resources and see if there's anything underutilized and then make adjustments. If you're a subscriber to AWS Premium Support, you'll also have access to AWS Trusted Advisor. AWS Trusted Advisor comes with a number of pre-configured checks. And when you run those checks, it'll give you information around idle resources or unattached EBS volumes. So if you're looking for a quick win today in regards to optimizing your AWS platform and you're a subscriber to Premium Support, you can run your Trusted Advisor and get recommendations around how you can do optimizations such as the ones I mentioned. In addition to CloudWatch and Trusted Advisor, you can also take advantage of third-party tools. So if we go back to the beginning of our discussion today, we mentioned things around the detailed billing report. There's a number of third-party tools in the environment called out on this slide that can ingest and look at that data and provide recommendations around right-sizing and decommissioning unused resources. After you've right-sized or decommissioned unused resources, the next step you might want to look at in regards to cost optimization is increasing elasticity within your AWS environment. And this has been particularly important around your consumption of AWS EC2. We look at increasing elasticity by we define it as matching your IT requirements with what you have provisioned in as near real time as possible. And this can mean increasing how you horizontally scale applications or add incremental units of compute. AWS Auto Scaling is an excellent way to help you match resources to the demand that your applications have. So I want to take you through a quick example of how AWS Auto Scaling can help you with cost optimization on a particular workload. So I have a particular workload running right now, and I have that running at an M5 2x large as an example. And depicted within this graph, you can see my white demand curve. And that's the demand that I can see over a 24-hour period and how it typically rises and falls based on typical business hours and how users utilize this application. In a traditional sense, we might have procured a large machine so that during hours 4 to 8, we have the capacity that we require to meet user requirements. But there's an alternative path, and that's through auto scaling. Auto scaling is, as I mentioned, the incremental addition of compute components. And in an example of using AWS Auto Scaling, we can auto scale 51 M5 large instances. So these are smaller incremental instances, as opposed to using a large server that has all the capacity that we need. As we follow from left to right, as the demand increases for our application, we add incremental instances. And then as demand falls back down, we remove them. And this can be configured within the AWS Auto Scaling environment on the AWS platform. How this works in regards to cost optimization is you're finely tuning and matching what you've provisioned versus what you need. And in the sense where we have an M5 2X large, which costs us $8,294 a month, if we move that to an auto scaling pattern, instead we can have the same amount of capacity that our users require, and we'll be billed instead $4,400 a month. So an excellent cost optimization mechanism to take advantage of, which is around elasticity. Similarly to Elasticity or AWS Auto Scaling, I'd always encourage customers to look at scheduling workloads if possible. Oftentimes, it can be overlooked where you have a development or a test environment, which doesn't need to be running 24 hours a day. It's often very likely where you can turn these resources off at night or on the weekends. AWS is a consumption build platform, so it's on demand. As soon as you turn off resources, you no longer have to pay for them. And in the regards to EC2 or other resources that we can schedule, you can automate those to be shut off at night, so you're not billed for those out of hours. Then you can also automate them to be turned back on during business hours. An example of where you did this during business hours, you could look at a 70% savings within the consumption of particular services with this kind of scaling. Now, there are a number of tools similarly to right sizing and how you can increase elasticity into your AWS environment. We have documentation, and I've provided some here, where you can look at guides to introducing auto scaling. So these guides will help you with how to make sure your applications can handle an auto scaling environment. In addition, we have information and documentation around how you can set up AWS instance schedulers. So these schedulers will help shut down and then turn on instances based on the configuration that you preset. So excellent opportunities to help you. But as there were within the right sizing activity, there's also third-party tools. There's lots of tools out in the market that can help assist with this. So if you don't want to go through some of the configuration yourself and you want assistance, and I've called those out below. Certainly take a look if this is an opportunity where you would look for assistance. There's prime players in the market to assist. Those first two pillars were really the step one and step two of a three-part journey around cost optimization for compute. After you've looked at right sizing and increasing elasticity, the next thing you can look at, which will have a large cost optimization impact for your organization, is the utilization of reserved instances. A reserved instance is a commitment over time in exchange for a discount. At AWS, we offer these term commits over a 12 and a 36-month term. And those commitments act very similarly to a coupon book. So they are not directly correlated to a particular instance. Instead, each hour the AWS console goes through and looks at the RIs that you've provisioned and looks at matching them with the service that you have provisioned that it can match with on the component. As we go through these coupons, I want to give you a deeper look, but it's really important to remember that they are just a billing construct and you don't actually have to change what you have running today. So those matching properties, when you look at procuring a reserved instance, what are the 4 characteristics that you need to look at? Reserved instances, when you purchase them, are tied to a particular instance type or an instance family. So in the example here, I'm referring to an instance family as an M4. So you have to look at what you're running today and then produce or choose that particular instance family. In addition to the instance family, you also have to choose the operating system that you're going to be using. So whether that's Linux or if it's some flavor of Unix or Windows, and if Windows is then associated with any database licensing. The third component you have to select is a region. And then the last of that is you have to select your tenancy. Most often, you'll be looking at a shared host, but also if you're running on dedicated host on the AWS platform, you can look at reserved instances as a discount or an optimization mechanism. Overall, what we see when customers look at utilizing reserved instances is that on a 12-month term, you typically have between a 20 and a 40% savings. So via that commitment, it's a great optimization mechanism. If you're looking at a longer planning cycle, so say, for example, 36 months, oftentimes we see customers can save up to 75% on their service cost by leveraging that commitment over those 36 months. It's also important to remember that reserved instances are not just available for Amazon EC2 and EC2 hosts. They're also available for a number of different services. That includes RDS, Redshift, Elasticache. We also have services such as CloudFront and DynamoDB that we offer commitment discounts for, but it's not necessarily a reserved instance. If you're interested in those, you can reach out to your account management team, and we're always happy to assist. So giving a little bit deeper dive into these reserved instances, because there's a number of different characteristics, wanted to explain to you the difference between shared and standard and convertible reserved instances. As I mentioned, both of them are on a 12 or 36-month term, but the difference between the standard and convertible is convertible reserved instances, which were introduced recently over the last 12 or so months, is that they allow you to change characteristics on demand throughout your term cycle. So those things that I mentioned around tenancy, operating system, family, and region. As we go through, how you can look at your payment terms is you can look at procuring these reserved instances no upfront, partial upfront, or all upfront. So those have different options in how you procure. As we mentioned, the tenancy and the operating system, but our key call out for this slide is that these orange components are what impacts the discount that you have at any given time. Giving you some greater information into those discounts. So if we look at payment options as we go left to right, all up front, so you have your largest discounts available. The 36-month terms have the greatest. Windows or operating systems with no associated licensing costs, the newest generation, and the standard reserved instances. On a quick side note, if you're looking at cost optimization, it's always best to run typically the newest generation of machines for Amazon EC2. As newer instances come out and we introduce price drops or incremental decreases in price, newer instances are typically cheaper. An example, if we look at C3s versus C5 instances, it's typically the case where a C5 might be a cheaper on-demand rate. So if you're running older hardware, recommend just taking a look at the newer things and if they can provide a pricing discount to you. But back in the vein of reserved instances. As I mentioned, those reserved instances on the convertible side, they offer you great flexibility in that you can change characteristics. So some examples of these changes that you can make. With the convertibles, you can take advantage of newer instances. You can make adjustments as business changes happen within your organization. And because you have this flexibility to make adjustments, you don't have to worry about the likelihood of unused reserved instances. How this happens is that you can make adjustments, as I mentioned, around changing instance family, size, and system, and tenancy. So really, if we look at convertible reserved instances, what we're committing to is the 1 or 3 years. We're committing to a region, EC2, and a spend. And I want to just go into some quick details around how that spend works. So examples of conversion and how you can change the commitments that you make on these terms. You can change to sizing to smaller instances. So for example, splitting a large instance into a smaller one, in this case of a half, and then you have no true up. If you do want to make an adjustment where there is a greater incremental cost, how convertible reserved instances work is you pay the true up or the difference in that upfront price. So an example of an M4X large moving to an M4 2X large, the upfront cost is $20 different as an example. So you would pay that $20 true up when you make that adjustment. Some other common examples that you might see is changing to a more expensive instance type. For example, adding an associated licensing cost on your EC2 instance. Or as another example, switching to cheaper instances. So moving from an R4 to a T2. So there's just some brief overview on how that works and then how you can look at convertibles and the utilization of them in your environment. Whether or not you're running standard or convertible reserved instances, there still is flexibility around the instance size. So you have the opportunity to change vertically the size of your AWS EC2 instance, if it is regional, if it is Linux or Unix, effectively not having an associated licensing cost for the operating system, and it's shared tenancy. So in that case, you can dynamically scale up from a large to a 2x large or scale down. So if you're looking at the commitments and you're comfortable with a particular instance family, but potentially looking at size adjustments over your term of that 12 months or so, this might be an excellent opportunity in how you can scale up or down within your commitment. So looking at AWS reserved instances, typically what you'll want to do is go back to one of the first tools that we mentioned was the AWS Cost Explorer. AWS Cost Explorer will allow you to see the demand, or the coverage, of your on-demand versus your reserved resources. And typically in your organization, you want to set some kind of threshold. So whether or not that's a 20% threshold for running reserved or a 50%. It's totally up to you and your organization and how you want to run your billing constructs. In the Cost Explorer, you can look at that utilization and you can make adjustments, or you can make a decision around purchasing RIs to cover where you want to be in an RI coverage pattern. It's also available in the AWS Billing Console to get recommendations around what reserved instances that you can procure. So if you go into your Billing Console and click on the configuration or the menu button on the left, you'll see a subtopic called RI recommendations, particularly around EC2 or an RDS. And if you select into that, you'll see a recommendation explorer, such as the one I have here, with the various different parameters that we discussed. So you can select the term that you want, the standard or convertible offering class that you want, the payment option, and then how you want to look at historical data for your recommendation. And upon selecting those parameters, you can see exactly how much you would save if you were to execute particular reserved instances on your account. So if you're running things today, this is a great tool to look at how you can make recommendations or where you could potentially run RIs. Once you have those RIs, it's then very important that you maximize the utilization for them because it is a commitment over time. Within the same Cost Explorer, you can look at RI utilization reports. And that RI utilization report, you can break out by account name and by the lease how much you're utilizing a particular reserved instance. If you have a standard reserved instance, this is where you might, and it's being underutilized, this is where you might want to re-look at what you're running and particularly assign resources back to those parameters under that standard so that you're maximizing that benefit. But if you have a convertible reserved instance that's being underutilized, then this might be an opportunity where you take advantage of that conversion process and then reallocate that reserved instance to something else that you're running in your AWS account. You can also set up AWS budgets, so you don't have to proactively always go in and look at those reports. AWS budgets is another area under the billing console where you can set up SNS or email notifications around those different metrics that we mentioned. So around low RI utilization, or for example, if our billing increases, we want to get a notification around that. All of those are available within AWS budgets and that you can set up. So that really summarizes the third pillar around reserved instances. The last pillar that you can look at, the second to last pillar that you can look at is the storage pillar. And how do we optimize the storage that we have provisioned on the AWS environment? If you're looking at starting on EC2, generally customers provision general purpose drives. It's the default, and it's typically what we would use. There are other options available, though, that based on your workload might be applicable. So if instead you can look at using throughput optimized hard drives or cold storage hard drives, these drives can help you save costs if they meet your requirements. In addition, one of the things that's important to remember around EBS is that the size of the drive that you provision matters. So you're charged for EBS by the volume size that you provision. It's not dynamic. So if you have an over-provisioned drive that you're not using, you might want to look at reducing that EBS volume size to match the requirement that you have so you don't have to pay for that excess capacity. The second area that we can look at in the fourth pillar around storage is taking advantage of different storage tiers within S3. So typically what you can look at as a life cycle is transitioning data from hot, warm, and cold environments. And where you might want to start taking advantage of additional services over S3 standard is looking at things such as standard infrequent access or even Amazon Glacier. These ones have different retrieval policies. However, they have different on-demand costs. So based on those costs and based on the retrieval policy, it might be a good storage option for you in regards to cost optimization if you don't need data readily accessible and if you have windows that are good for your business for retrieving that data. The last pillar in cost optimization that you want to look at is designing for cost. And this really starts from the beginning of your development or onboarding applications into the AWS environment. There's lots of different design patterns that you can utilize. One of the main really important things is work with your AWS account team and your solution architects to determine how you can take advantage of these different components. So to highlight some quick ones or some quick wins is potentially look at using Amazon EC2 Spot. So Amazon EC2 Spot gives you the capability to bid for unused capacity on the platform. And by bidding for that capacity, you can get it at a cheaper rate than the on-demand price. In addition, you can look at designing applications using serverless or AWS Lambda. And the utilization of serverless allows you to pay for effectively just code executions and not for the overhead of running and maintaining servers. So very cost-efficient pattern to use. A third one that I'll call out is potentially using open source platforms or databases. AWS is a very friendly ecosystem in that we allow a lot of different platforms based upon your requirements. So if there's an open source platform that you can take advantage of, I would recommend looking at that and how that can help your organization. So as a summary, as we went left to right, so we talked around the right sizing and the decommission, elasticity, and reserved instances. And as I mentioned, that's like a step 1, 2, and 3 process. So if you're looking at optimization around your compute, you can work through those 3 steps. After you've done those steps, you can look at your storage. And there's typically a quick win to be had there around potentially lifecycling information or reassigning EBS volumes. And the last one was the architectural optimization. So taking advantage of emerging services on the AWS platform, such as AWS Lambda. The last area I want to go with you really quickly is around optimization mechanisms and strategies. And this is how you bring these elements into your organization. When I look at customers that look at doing cost optimization, there's no right amount of time that you have to spend on it, or I would say guide to get it exactly right. This is something that you need to look at in your organization and determine how often you're going to go through a cost optimization practice. It could be a monthly review or a quarterly review. Effectively, it's a cyclical pattern. So as you establish your visibility, look at how you can get quick wins in regards to architectural optimization. Then look at how you can introduce mechanisms in. So we mentioned mechanisms throughout the discussion around potentially setting alerts for budgets or for RI utilization. How do you establish those within your organization? And then how do you continuously have quick wins? So as we get in that monitoring, we go through this path and we repeat. AWS has a number of different resources. So I mentioned I had links during today's presentation around each of the core topics, but there's also a number of other things that you can take advantage of. AWS support is an excellent resource. So if you're looking to get assistance via chat or email or phone, you can look at having AWS support for assistance and guidance. You can also leverage your AWS account team. So as I mentioned, I'm part of the account management team here in the Australia region. And my role is really around helping customers have wins on the platform. So engage with your account management team. And then also look at the AWS partner ecosystem. So we have a large and diverse partner ecosystem. And in my experience, AWS partners can really help you accelerate value and help get wins with your journey into the cloud. As I mentioned, we have different forms of support, professional services, and the partner network. Make sure you take advantage of all of these. So as a summary, we went through those steps: the establishment of visibility, how you can look at optimization mechanisms and strategies. And what I now want to do is take about 5 to 10 minutes to go through questions. So I know people have been posting questions throughout the discussion, but I'm going to be here hanging around. If you have any additional ones, I'm happy to answer. While we're also doing those questions, I want to ask if we would stick around for some feedback. So one of the core things around AWS is listening to our customers and their requirements. So we're always keen to see how this presentation went for you and if it was helpful. And that presentation feedback is really important so that we can align content for the next time we go around. So I want to say thank you. I'll be here to answer some questions. And good luck, and I hope you have a great Amazon Web Services journey.